Good morning to everybody. Today I'll be talking, most of the things you have heard, I've given examples, and based on all this experience, what you have gained and what I shared, I'll try to use those examples so that I can save time, and you can again try to remember what I said, you can relate. That will be easier, I think. Having said that, then some of you may think, oh, maybe this old professor did only these few things. So I tried to add something new, but not too many things, at least one new thing, one new riddle in it. That also I tried to complement it with example. So this is what I'm going to talk today. And I'm sure all of you, or not all of you, many of you, either learning or teaching research methodology, correct? And when I was asked to give a talk on this topic, I didn't know that there is a subject, research methodology, being taught as a course. So after giving the talk, when I came to know about it, I tried to go through the notes, what they teach. So what I felt, if I'm wrong, please excuse me. And at this age, sometime we dare to say something contradicting. So I found that what they teach is not what they should teach. They should not teach it, because I always tell stories. When I went to learn golf, being I'm not big figure to play golf, but I took it as a challenge, that because one of my colleagues told me, you short guy, never ever try to play golf. And finally, I took up golf so seriously, he was one of my students. He was my colleague, and he would beg to give him lesson on golf. And should I tell that unbelievable, I was a champion of Malaysia, Singapore. I was champion, I was runners-up. So everything you take. The thing is that the golf coach told me, he gave me one lesson and said, after this lesson, if you at all go for any lesson, please come to me. Don't go to any other instructor. I asked him why. He said, I taught you the swing. That is the main thing in golf. If you have a correct swing, distance automatically comes. People talk, Tiger Woods, big figure, he can hit. Definitely they can hit longer, but height matters little bit, but it doesn't matter too much. In golf game, accuracy is most important, and swing, if you have the correct swing, you get your expected desired distance and point. So he said, if you learn from somebody a wrong swing, here today you learned swing in one lesson. If you learn a wrong swing from somebody, I will have to give you 10 lessons to correct. So de-learning the wrong thing takes 10 times. So better not to learn the wrong thing. What I saw, I was puzzled. Maintain logbook, write how do you do, what you are doing, this and that. Research is something, it should be, I feel, it should be spontaneous, and to create that spontaneity, we need to develop the thinking process. I can tell you, I will not teach you, I can tell you the process, but everybody will have to nurture it. Everybody will have to practice it. Build a culture of research in yourself, in your team, in your surrounding. And once you do that, then that will be the real methodology. What I'll be talking to you is not teaching, I repeat, talking to you the way I thought that thinking process should be developed. And these things, again, going through my long research years with students, colleagues, and even from surroundings, I build up this habit of some of these things I'm going to share with you. And in between I'll try to make jokes and I'll give you some puzzles. Some of you might have heard about it. Those who have heard that, please keep quiet. And even my anar pomegranate pomegranate juice drinking. Anybody have seen? Anyone you have seen it? No. If not, then it's okay. If you have seen it, just keep quiet, close your eyes. But today's job will be difficult because usually I do it with a very big, ripe pomegranate. Unfortunately, today's one is very raw, very young. Difficult to apply my technique, but I will try. So let me go to the slides. Today I'll be talking, sitting, relaxing, sharing with you, because when I'll be telling jokes, then if I stand up and tell it, it looks like very serious. But at the end, sorry, my request to you, don't go outside and say that he's a magician, he's a joker, he's not a teacher. So, anyway, let me come to the presentation. It's not, I usually give the talk how to do a good research. So when I saw Prof. Jose Matthew said, he added few words, art of conducting. I really appreciate that. I think that is the way it should be done. So I learned an art of writing from Prof. Jose Matthew. So art of giving the title of a topic. Okay. So that art of conducting a good research, and I have given it a few times, and I modify a little bit here and there every time. Okay. Let us start with what I'm planning to talk. What is research, and what is the difference between search and research? Then, how to choose a topic? Is there any? You will have to look whether there is innovative element in it. And what is innovation? I've spoken many times, but I'll repeat. Examples of innovation, how to be innovative. Okay? And one is applying fundamentals, and then how to define a good researcher. So go back and evaluate, are you a good researcher? If not, how to be a good researcher. Then how to conduct research work. As I told many times, that to conduct a research work, it must be, analysis must be done, experiment must be done, validation must be done. You can do experiment and analysis, or analysis followed by experiment. So either way. And then how to write your thesis, or how to write a paper, and conclusions. Now writing in everything, writing is same. Whether you write a paper, or write a thesis, write a report, write a research proposal, writing pattern for engineers or scientists, it is same. So don't worry when it comes to research. I will, after giving that talk in the afternoon, about the writing a research paper, I'll highlight where is the difference between writing a research paper and a research proposal. Okay, here again I start with a story, which is thing. When I was asked again somewhere to give a talk, because one professor said, Prof, we have listened to you many times about your research papers, research achievements as keynote speaker and as a normal speaker. But this time you will have to give a paper, give a presentation on how to do a good research methodology. So I got a shock. I never studied it, I never taught it, I never gone through any text. So, as I told you, teacher remains teacher forever. So I called my professor. He's 80 plus now. So I said, sir, I have been asked to give a talk on how to do a good research. What do I do? So he took it very easy, he laughed at me. Rahman, are you fooling me? I said, why, sir? So he said, you are a good researcher. I said, no, sir, I'm still learning from you. He said, no, no, no. So then, sir, what should I tell? He said, take it easy, tell your life story. That's all. I said, oh God, he saved me. So exactly same thing, I'll be telling my life story. I'm good or bad, I do not know, but how I did it and what I did, I'll share my life story with you. Okay? The parts, yes. You have any question? No. Okay. So I'll tell my own journey from student to a research engineer. Where is the pointer, please? Pointer, please. So my own life journey from student to researcher. Yeah. Researcher, from researcher to an engineer to an US teacher. And now researcher, innovator, entrepreneur, whatever you call. And those irrelevant stories I will not talk. I will, from student to research engineer, not luckily, not student to a politician, their journey I will skip. Now, let me go back to the content. What I mentioned is difference between search and research. I'm sure all of you know that searching, you lose something, you search to get it. Or you want to get something, you look around and try to find it. But we are not searcher, we are researcher. What is that? If you search, you don't get, okay, look for another thing. But in research, it is not that. You decided to search something, you fail. Do it again, never get frustrated. Never get frustrated, never give up. Give up and cannot be done. These two words should be deleted from your dictionary. Can be done, must be tried. At the end you may fail, doesn't matter. But definitely your search, if you do it a thorough search, something will come up. You might have started from Calicut to Dhaka, if there are flight disruption and so on, but the purpose, you may not have to go to Dhaka, you may end up getting Punjab, you may get it there. If it is there, go there, because normally one place, not one place in earth that everything is available there. So we do continue to search. And if you have the conviction, and your conviction is substantiated by analysis, then you are sure to reach there. The goal may be slightly different, but definitely it will be a wonderful goal. So be a researcher, don't be a searcher. And don't try to make a shortcut trip, never. If you try to do shortcut in research, like if you get something, still you do, redo, to confirm, reconfirm, substantiate, validate and prove it. Okay? Professor Rakesh was saying yesterday, again and again, we need to validate repeated experiment to prove that I am right. Just superficial knowledge, you may be wrong and you will be fooled one day. So have the conviction, repeat it and get convinced. So what is our difference with search and research? Now about our responsibility. What scientists think of us, I told earlier, Einstein, engineers create things that has never been. So he has so much of respect for us, so we will have to do it. We are scientists, applied scientists. They are scientists, but we are applied scientists. James Meshner, a brilliant, international brilliant scientist from USA, he says scientists dream about doing great things, engineers do them. And all these quotations are written in NUS walls. One in our corridor, another in the wall of engineering building 3. Yeah. And I didn't add one thing I might have told when I give a talk on innovation. Before that I go at home, I practice with my wife and children. My youngest son told engineers make dream come true. Oh, this year, engineers make dream come true. So, how to do it? You will have to do it by innovative ideas, and you will have to think of innovation. So, all engineers are expected to be innovators. So, content of this talk is how to choose a topic or research topic. Is there any, when you choose a topic, first thing, as Afzal told in his talk, that when he came up with some proposal, what I wanted to listen from him is there anything innovative? Is it me too? Does it have a fantastic idea behind it? Is the goal very high? So all these things you will have to think. So it must, whether, and I'm sorry to say, when I talk to many, not here, students usually in our subcontinent, who gave the topic? A supervisor gave it. I'm sure there are some students, my request to the student, don't do that. If the supervisor says, argue with him, sir, why should I do it? What is good in it? What is bad in it? What shall I achieve out of it? If the supervisor gets annoyed, don't annoy him, after all he's supervisor, but try to put it in such a way that he's happy to answer your questions. Don't make a mistake. Prof. Rahman said, I should ask my supervisor, that's why I'm asking you. Don't do that. Okay? It should be very cordial. And to the supervisors, my earnest request to you, never ever give the student the topic that it is. Then it becomes an experiment. Whatever idea you have, he becomes so dependent on you. Sir, I have done it. What next? Sir, I have done it. What next? And in my life, I never called a student to ask him, what have you done? They would rather come and say, sir, this I have done, just for verification only. Or if they have a problem, sir, I'm trying, but something difficult. And I allow them to move in a path they want to go. Whether they will go straight north, then east to reach the diagonal distance, or they are trying to go diagonally to make it in the shortest possible time. So if they go too much to the left, I bring them to the center. If they go too much to the right, I try to again bring to the center. So you are supposed to be guide. You are not supposed to be lab supervisor. So please remember that. And students also, don't try, if you are stuck with the problem, please go to the supervisor. Otherwise, try to think. Once you get your thinking process established, then it's very good. And don't think that your degree, master's or PhD, is not to get a degree only. Even in engineering, what I tell my students, my colleagues, that what is the difference between engineer and science graduate? Engineering, we apply the technology. So it's a discipline where we train them to produce things, to make things, for that to think about something. It's a system we teach, believe me. In science they teach the fundamentals. We teach the application of the fundamental through a systematic way. Okay? When we teach design to our students, we start design from first year, because ultimately we want them to be a good design engineer. We start with paper design, then design on paper. Third year, they make small things, what they have designed, and final year we give them project to do. So everything what we want to say, that engineers learn how to do things systematically. Where I was. Then examples of innovation I have given some, I will give some more. How to be innovative, applying fundamentals, then good researchers, how to conduct. These things I think I'm repeating from what I said earlier. Now ultimately our target is to achieve something. And achieving something containing within yourself is not enough. You'll have to write a thesis, you'll have to get your degree, then you'll have to publish papers to get recognition, And some supervisors or institutes say you must have 3 papers, 4 papers. I think that condition should not be given. Honest request to the supervisors, get them, first of all, let them do a best possible research and inspire them to write them in papers and write good papers to be published in good journals. Those who are pushing the students to write papers, I think they badly need papers for their promotion. And so try to target high impact journals, high citation and so on. So for that you need to have, so I'm talking about the ultimate target, good thesis, good paper, and your journey is the research journey. So that you should have a very good idea, innovative idea or some concept, analyze it, verify it experimentally, or it could be the other way. If it is very high impact journal, please remember, idea, concept with a significant breakthrough in it, not just improvement of something. Improvement is fine. If the improvement is breakthrough improvement, something new comes out, fine. But if it is absolutely nobody has thought about it and you have done it, that is breakthrough. That is called breakthrough innovation. I think I have defined in many conferences incremental innovation or evolutionary innovation and revolutionary innovation. So think of revolution, something somebody will listen to you and say, wow, target that. And that you can publish in high impact journals. Okay? Now, all these publication, degree, and again I told about relevance. Again, go back to the fundamental, go to the basic, is that to remain relevant, you will have to increase your, if you remain relevant, your visibility will go up. Correct? Everybody wants, everybody in this world, visibility. Who wants to judge it in your own way? So our target would be to increase visibility and image of whom, of what. First of all, individual, because I need to remain relevant, to be visible, so that I get my promotion, I get increment, I get recognition, I get more students, I get more funding, I get all these things. So I need to increase my own visibility. And if you try to increase your visibility on your own, please remember, in this world, how much work you can do in your lifetime is not very important. How much work you can get done, not selfishly. How much work you can get it done, that is very important. Because when you concept your paper you publish in a journal, journals, reviewers or publishers, they are not bothered how many authors are there. If a single author paper, some people say it has high value, but the value is in the content. It is not number of authors. Nobel Prize is shared by 2, 3, 4 people even. So does its value go down? No. Still Nobel Prize is Nobel Prize. For the same topic, 4 people get it, so what? Maybe same paper, same concept. One Japanese professor, one American professor combined, they got this last year's Science Nobel Prize. Sorry? 10, 20 does not matter. Nature papers you will see many. I have seen a paper actually, doctor from electrical engineering, my student who did laser machining with me, he joined electrical department to do more laser machining. That time we did not have any device, he used electrical engineering laser device, and he wrote a paper making multi-lens arrays using laser in micro dimension with nano finish. 10 authors. Nature is nature, Nobel Prize is Nobel Prize. Number doesn't matter.
In that scenario, if you want to get the weightage, one paper or point divided by the number of authors.
No, it should not be. Should not be, because
There are other cases, some people are misusing that also. What is the result? Is it done the right
That is unfair. Fairness should always be there. If I do not contribute, why should my name be there? When I came back from Tokyo, started doing research in NUS, out of respect and honor, I was putting my supervisor's name, because all the concepts I developed in his lab. So I owe him. So I put his name and I sent it to him, sir, could you please go through? So he would go through the paper and just delete his name. He would say, Rahman, why? Do I need more papers? He got 2 gold medals. Do I need papers? No, I don't. If you put my name, I'm very happy that you have put my name. And I'm doing my fair job removing my name. And then I said, sir, shall I dare to send papers every time to you? She said, until I die, you do it. And he's a very wonderful guy. When I was very sick, sorry, I became emotional, I'll not be able to tell you. Oh, can you connect it, please? I was very sick. So he said, I want to meet you. Would you like to come to Tokyo, or I'll come to Singapore to see you? So my wife said, let us go for a break. We went, and he said, he doesn't believe in God. So he simply said, don't die before I die. I do not want to see that my students are dying before me. So such a wonderful man. Okay, so individually you want to, but sharing it, Afzal told a little bit about it yesterday. It talk was the day before yesterday, that in one time my group had 13 PhD students, and we would be sitting once a week. In your time it was 7-8 students, but once I had 13 PhD students with my colleague, and every week they meet, and one of them must present. Sometimes it's more than one, they present. Why we were doing it? I could have called one of them and listened to them. I didn't do that. I was doing it in a group. Can you guess why was it? Huh? It is common discussion for their benefit, because doing one PhD project, he knows about other 7 or 8 PhD works. That is his benefit. The benefit of the whole group is that, and we allowed them to criticize each other. Criticize in a sense, even severe discussion is allowed. And they were discussing, brainstorming, and everybody knew everybody's project. Even when writing paper comes, somebody is writing, rushing, others are coming and drawing the figure, helping him, no name. Sometimes accept acknowledgement only. And they were helping each other. So that team spirit we developed. Even I'm sure most of them, all of them are in touch with each other. I can ask, hey Afzal, what is Akshay doing? You'll be able to tell who is. But I'm not in Facebook. I'm sure they are somehow communicating with each other. And so that benefit is there. So try to cultivate the culture of group learning. They are benefited, and in one sitting, you know who is doing how much, and you don't have to keep record, is he doing proper work or he is hiding, or the team spirit try to build up in the group. And even intergroup relationship is very important. When we could not solve Afzal's problem of building the circuit, Professor Panda, I found out Professor Panda is good in that. I told him, actually I caught him in a canteen, you remember, and he was so busy, but while he was having lunch, he gave the idea, called his student and dedicated the student to Afzal to help him. So that way, what I am trying to say, it is not that how much you can do, how much you can get it done, not selfishly, selfless. You go to Panda, he went to Panda, we went to Panda, he taught us, but he felt very good that he did something good for another student, if he's a good man, and he's definitely a good man. Otherwise you would say, no, I have no time. And I don't think there is anybody in this world, if somebody comes to learn from you, you will say, no, I'm not interested, no. Because you are getting your recognition, that somebody recognizes you, you know about it. That is the beauty of it. You are not going to borrow money from him. You are going to learn something from him. Okay? And that's why I always stress that in my group there are in our group I should say, 14 teachers in manufacturing. And for some reason, senior most 2 of us were in machining. But the other guy decided to move away from machining. He went into software guy. He built his own group. I had to build my own group. I was luckily, I was also 7 and he was also 7, 14. But luckily we drew a lot more fund because industries are willing to fund our projects. Okay, so if you work in a group, for instance, if you have a manufacturing group and inspire the group to grow, get the work done, publish more papers, though one member may have very little contribution, you recognize him, take him into the group, try to activate him and get publication. He got inspired, group output becomes more. In my group, I might have told you, I didn't know anything about EDM. But I saw that to do compound machining, I need to learn EDM. So EDM guy, Professor Wong Yok-san, I tried to work with him and he was very happy. So he was working on EDM, I was working on conventional machining. Combined together, I had to learn something. He learned something from me. But worst thing happened, one of my students, Arif, when we went to Simtech for a job, so the director interviewed him. They interview in 3, 4, 5 stages, finally director. So director interviewed him and said, yes, I know you are a good student, but how come Professor Wong Yok-san is your supervisor? So Arif said, yes, he is my supervisor. But he doesn't know anything about ultra precision machining. No sir, you cannot say that. He knows. At least Prof. Rahman recognizes that Wong Yok-san knows ultra precision machining. No, he doesn't know anything. So Arif said, sir, you are allowed to do anything and everything, but never ever undermine the position of my supervisor. My supervisor is next to my parents. So the director argued with him and said, okay Arif, see you. He came back and told me, sir, you sent me there for the job. I'm sure I'm not going to get the job. I said, why? He said he was very annoyed. I was very annoyed when he said against something about Professor Wong Yok-san. And I found him a fantastic supervisor. And he said, no, he's EDM. I argued with him, no, how does it matter whether he's EDM but EDM or machining? He's my supervisor. He's a knowledgeable guy. He's a gentleman. He's a nice man. I said, definitely you will get the job because director wanted to see what is the respect for your supervisor. Exactly same thing you would expect from you when he's the director and you are his employee. So reluctantly he believed it and he got the job. So anyway, going back to the group. Group is important, and I worked with 3D printing, Jerry Fu, everybody. So long they are in manufacturing, Feather or carries the title manufacturing group, we are there. And that way you increase your, most important, that way you increase the visibility of the group. Kali, if you take any institute, I don't know, I won't name, Bombay is known for some area of research, Madras is known for some area of research, Kharagpur IIT is known for some, because they built the group. Now, whether they are maintaining it or not, I don't know, but try to, wherever you are, try to build your own group. Because every institute need not excel in everything. Focus, that was NUS doing. NUS was doing that. Focus in few areas, excel in it, build your reputation, build your visibility, build your output, everything. So that is very important. And when it comes to the department, if each group, if few groups excel, the whole visibility of the whole department goes up. Oh, such a department in such an institute, and there again somebody spearheaded it. Okay, so you will definitely get your own credit. And again, institute. If you look at, I told you again, NUS. Luckily, our manufacturing group is so strong. I think we have a good name. We have a good name. Even our president was very proud to say that if any visitor comes who is in manufacturing, I will definitely bring it to your lab to show him. So for this, overall visibility increases. So our target should be do good research, and that through that increase your visibility. And that way I think it will help in ranking as well. Will increase and improve our citation, reputation, profile, etc. Okay? So that way we try to remain relevant through a good research. Now, sorry, very selfish part of this. You will have to see where is the current trend. If you try to go against the trend, you are a loser. Be on the trend. If you are so convinced that future is there, by all means go ahead. If you know the future is here, some work is going on, ride on the wave. But don't be me too. Ride on the wave, give your impactful input, excel in it, take it to the second level, third level, higher level. Okay? So selfishly I wrote here that current trend is micro nano manufacturing. Manufacturing could be in many areas. It could be micro machining, micro machining, nano machining. It not be machining, it could be 3D printing, it could be making new structures, as Professor Rakesh was saying yesterday. New structures, new ideas, new products. Okay? So think about it. Try to be on the wave, so it may be an appropriate time to get involved in the mainstream, always. Don't try to go against the stream, go ahead of the stream, and even start a new one, which you think, you are confident it will make an impact, go for it. Never ever try to do me too. Okay? Now let us come to innovation. To be an innovative project, it should be one of the following. The topic should have an original idea or concept, or it should be a significant enhancement of an existing idea. It should be idea, concept with significant breakthrough. Please take time to decide your topic, but don't rush. And test it, verify it, physics, maths, whatever is necessary, apply those. Okay, I think innovation, I have told it many times, with development of relevant product is innovation, which is others are yet to develop. Applying innovative ideas, remain relevant to survive. Please remember, you need to survive, you need to remain relevant through development of, I told you about the endoscopic camera tube in my life, and do something to improve the efficiency of the existing production system, applying innovative ideas, solving problem which cause, please remember, ecological or health problem. Most important is that you see people are moving away from fuel-based engine to battery-based engine. From battery, next one will be fuel cell, and next what we do not know. All right, we skip the next one. Now, what is the thinking process? Here, actually, the presentation starts. All I am putting up here is fundamentals should be applied. I gave you an example already, I don't have to elaborate much on it. Micro shaft. How did I machine a 50 micron shaft? From there, I moved to go to 5 micron shaft. So, applying the fundamental knowledge. You will have to think out of the box. Don't say, cannot be done. Never do that. Cannot be done, cannot be done. Think about it, think about it. Think out of the box. Now, out of the box thinking, I'm not trying to blame my parents. The society is like that. Our society is like that. They put us in the box. Do you agree? When a child starts to walk, parents, seniors, hey, don't do it, you will fall. Let him allow him to fall, take care when he is about to fall, picking up. Why do you say, hey, don't walk, you will fall? No. Never ever give negative impression to children. Let him try, but be careful so that he doesn't fall, that's all. If you say, hey, don't do it. You will have to say, if you try to walk, you may fall. Be cautious. My wife is not here. I'm really thankful to my wife. Every house, children break this thing, that thing, that thing. So they put everything somewhere, show pieces and good pieces. My wife never did it. He should say, all my boys, so he would say, Abu, father, Abu, don't touch it. You may break it. He cannot talk, but he says, his mother says, don't touch it, you may break it. So don't touch it. It's a nice piece, you like it, we like it, don't touch it. Then he would go and say, oh, Ammu, no. Ammu, you said, that's why I'm not doing it, but I want to touch it. And every piece was there, safely, peacefully. I'm really thankful to her. And everybody would say, how come everything is intact? She says, this is the way. We agreed to tell the child, don't touch it. Please don't touch it. If you touch, you may break it. Same thing. If a small child wants to put his finger into fire, nowadays luckily there is no kerosene lamps. People would love to touch it. No, don't go there. Allow him to go there. When he about to touch, he said, hey, you may burn your finger. It is very painful. Oh, okay. So that way, don't ever try to put the researchers into the box so that he is not allowed to think out of the box. Allow him to think anything. I repeat, Afzal said, sir, how about doing that? I just, what is a rubbish idea? No. Okay, argue with me. If it is good, fine, or by all means do it. If not, don't do it. But I never told him, you must do it. I told him, subtle way, that how about trying arcing and sparking, because that was my dream project in my mind. Again, I want the students to graduate quickly, rather than hanging around for 6 years, 7 years. So, if you have a strong conviction as a supervisor, pass it to the student, but not forcing him to follow that path. Very subtle way, try to inspire that, hey, if you can do it, it may be patented. If you do it, you will get a breakthrough paper. And simple bet is that if you do it, you may get a CIRP paper. Okay? And so, allow them to think out of the box. And all these examples I'll give. And the third one, I will test whether your parallel processor is on or not. To be a good researcher, remember, you'll have to have your parallel processor on. I'll give a puzzle to you today, and there is no example here. And you'll have to be very up to date with what is going on. It is not writing a poem that you have written a poem and nobody has written it. But if you do something which others have done it, then they will say, oh, you have copied it. A poem cannot be copied exactly, but a research becomes a copy unknowingly. So you'll have to be up to date. If you are up to date, that helps. Like my ductile mode machining of brittle material, 1976 paper. What happened? Okay? So now I go into the details, but some of them example of innovation in manufacturing. When I try to do compound manufacturing or shaft manufacturing, making, I'll skip that because development of micro machining process, I've told it. So this one, title was, so first title, fundamentals should be applied. Correct? And example is, making the shaft, you will have to know this equation. When you talk about deflection and force, then you should have the mind to remember what you learnt in an undergraduate. So that fundamental comes in, you apply it and do it. Okay? Now how do it, this I'll skip quickly. Then out of the box thinking. As I give the example, combining EDM and ECM together. Even though I did not do EDM, I was not my subject, I learnt EDM. When I gave this project, he was asking me to give a project, he was begging because his background from Vietnam, I know my background from Bangladesh, we had no research background. Those who go from India, they have some research background, no doubt, but student going from Bangladesh, I had no research background. I did not know. In the book I studied what is damping, acceleration, vibration, everything, but a structure may have a damping, how it is and all these things. I had to do stability analysis of machine tools. So looking at the Vietnamese student, when he said, sir, give me some project, don't force me to do it. Then I gave him this challenging project, story I have told, and he did a fantastic job. So hybrid EDM ECM I have discussed already, so I will skip that also. So I am saving my time today. Do I need to elaborate? No, very good. Oh, today I will show you something which I could not show yesterday, the results, correct? I don't know why I copied the wrong slide. For the red line, which is only EDM, RA was 142 nanometer. The blue line with compound EDM and ECM or simultaneous EDM ECM was 22 nanometer. Mirror finish. And shape accuracy was very good. Okay, now parallel processors should be on. I will test the parallel processor. I will not pinpoint to anybody. Those who can give me the correct answer, just raise your hand, and those who have listened to my presentation earlier, just please keep quiet. Are you ready? A parallel processor, interesting. Here I should tell you a story. Why I got so inspired. I was going to my room. In the lift, I met a lady who was the deputy secretary. She is supposed to be promoted to secretary of the whole faculty. So I met her in the lift. She said, sir, I am going for the interview. What interview? Promotion interview. She said, please pray for me. She said, Prof, how do you think so many things parallelly? So jokingly I told her, our parallel processor is always on. So she had no time to think about it. What is this parallel processor is on? Because immediately she will have to enter into the interview room. So she went for the interview. After the interview she came to see me, thanked me. I said, why? She said, Prof, I don't know why I asked you the question, but the answer you gave me, I think my promotion is confirmed. I said, why? She said, Dean asked her, hey, you so far in so many years, you were just following the instruction from the chief secretary, main secretary. Now, she has retired, you will be the main secretary. How will you take care of all the departments? You are just helping the secretary. Now, you will have to take care of all the departments. How will you do it? So she says, oh sir, don't worry, my parallel processor is always on. I said, then, he said, though you did not explain me, when the question came, I knew, oh, this is what Prof said. Okay? So the secretary got promotion because the parallel processor was on. Now I will test your parallel processor. Okay? Ready? How many of you claim that your parallel processor is on? 1, 2, 3, 4, 5, 6. Okay. Please remember, who committed, I will not tell that you said, why can't you answer it? So anyway, so about 5, 6 is parallel processor is on. Anyway, I am not putting burden on you. Vinod knows it, correct? Yes. Okay, parallel processor is on or not. Afzal also you may know, so keep quiet. A magician needs to create a background so that a simple thing, people get mesmerized and they cannot answer. I am not a magician, but let me try. You start your journey from Calicut to Dhaka, and Indian government and Bangladesh government signed a pact that they will connect these two countries through road communication, and people will communicate, people will travel from India to Bangladesh by bus, which has already started. From Kolkata we have bus, now we have bus from Assam, we have bus from Nepal, and most likely it will come soon to, if not Calicut, to Chennai, because now we have direct flight from Dhaka to Chennai. I was so surprised, I was so happy I didn't have to come to Kolkata to Chennai. Something went wrong. What is that? Anyway, so imagine that a bus is there to take passengers from Kazikode to Dhaka, Calicut to Dhaka. Bus is a big bus, it takes about 100 passengers. So Dhaka is not known to people from Calicut, but once upon a time Communist Party of Calicut was very strong, and Bangladesh also, Calicut, Communist Party was very strong. Of course, West Bengal was very strong. So some people, for many reasons, either to see the comrades in Dhaka or something else, or to buy, ladies going there to buy Jamdani saris, Bengal saris. So bus had 10 passengers. It started the journey with 10 passengers. Then it went to Chennai. In Chennai, another 5 got into it, and nobody got down. From Chennai, it went to Bangalore. In Bangalore, it picked up 17 passengers, and some people thought, no, Dhaka is too far, let me get down. So 5 got down. From Bangalore, it went to Pune. Pune, again, some people say, no, I'll see Ellora, Ajanta, and no more journey. 10 got down, and 7 got into it. From there, it went to Bombay. And in Bombay, fantastic place for shopping and jewelry and whatnot. So 12 got down, and 7 got in. From Bombay, it took a long journey to go to Delhi. In Delhi, 10 got into it, and 2 got down. From Delhi, it went little left to, they knew that Prof. Rahman is teaching there in Triple IT Jabalpur, so how is the place? We went there. 5 got in, and 2 got down. From there, it went to south, Bihar, Orissa. It took 5 passengers, and many got into it. 15 went to Kolkata, and 10 got, that I think 15 got in. Nobody got down because Dhaka is so near. Okay? On the way, the bus stopped at Jessore. In Jessore, 7 got in, nobody got down. Went to Dhaka. Now my question is, are you ready? How many places it stopped? 10. How many places? How many places? No common answer. At least some are correct. But I expected everybody to have his parallel processor on. There were only 2 things, either number of places or number of passengers. I thought 100% would be able to answer, because I warned you to switch on your parallel processor. So how can you be a good researcher? So please, and so It's nothing serious, but the thing is that when you are doing research, your parallel processor is not on, you will not think of alternatives. And you will say, oh no, it cannot be done, abandoned. But you have committed to someone, committed to the student as a supervisor, and the student is supposed to be very dedicated and serious. If the parallel processor is not on for both, then team will not work well. And there are so many options, alternatives. You have to choose from there. On that very moment, you'll have to think of alternatives and feasible alternatives, look for it, search for it, go ahead with it. So, what percentage passed, Prof. Just Matthew? 10% passed today? This? Yeah. Yes, that is, that's why it is riddle, otherwise it is not. So, maximum I think 20% passed. I doubt whether it is 20% or not. Not expected. So at least after this, if I come second time with such a riddle, with 3 factors or 4 factors, so that you cannot finish writing, I'll see it. Okay, so keep your parallel processor on. Having said that, in project, I have given you a lot of, in my examples, so alternatives. I'll give you another example. Okay, because of this parallel processor on, always be inquisitive. When I saw the bubble in EDM thesis from Japan, I'm really thankful to God. Immediately it came to my mind, oh, it must be ECM. Because, and travel by bus, you try to reinvent the wheel. Never ever say that it has been done. Nothing is complete, nothing is done. Everything is dynamic, everything has something new to look for it. Of course, if you say 1 plus 1 is 2, if I say no, 1 plus 1 is 2.5, that's not true. Fact is fact, fundamental is fundamental. But applying the fundamental, you can do a lot of things. Very simple one, I will tell you again. So let me have some water. Because all of the examples you have seen, I'll give you some new examples. Very simple, don't tell me I'm just, I'm not joking with you, but very simple way of doing it. When you are happy to do things, something in one way, try to think of other ways to do it. Okay? Very simple example. How do you multiply? I'll give you some example. 10 by 10 is, I give it to the school children, so I hope you'll excuse me for my silly thing. 10 multiplied by 10 is 100, 20 multiplied by 20 is 400. But when somebody asks us to do, hey, what is 13 multiplied by 17? How do you do it? I don't want the answer from you. Usually people say that 17 multiplied by 10 is 170, then 17 multiplied by 3 is 51, so it is 221. Have you ever thought there are other ways to do it? Luckily you still do it orally. People, school children, they will take the calculator immediately. But try to tell them, don't use the calculator. Simple things, try to think and do it. That way they can develop their thinking process. Is there any other alternative way to do it? Sorry? Minus 3 into. Any other way? Right way, but there is another way also. I want to see how many ways you know it. You are almost there, but you could have made it a little easier. Yeah? Sorry? Make it, try to do it in shorter steps. Sorry? Yeah, minus plus. Look back into that. It's a very absolutely silly question to ask, I know, but just to see alternate ways. I give you some hint. 10 by 10 is 100, 20 by 20 is 400. If you look at 13 and 17, they all lie, both the numbers lie within same 10, correct? So what we are trying to do, left side is 10, double digit, right side is single digit. So if you take, in 13, there are 13 tens, correct? So, and 17 has 17 tens. These are a game of tens. So why don't you take these three, borrow from here, pass it to 17, it becomes 20. Which you have borrowed, deducted from it, it becomes 10, correct? 10 multiplied by 20 is 200. You have taken care of the left side, what you have done already. Then right side 21, so 221, correct? So there are, and I think one of the easiest way to do it. And we learnt in our school, if you want to add 1 to 10, first number plus last number divided, if it is odd number, even number, divided by 2 multiplied by the average number. They never told us why it is. Have you thought about it? Why, how the formula came, we don't think, we take it granted, we put it in the formula, no. Please think about it, how the formula has been. It could be simple, but from simple, you can think of even Fourier analysis, whatever is very complicated maths, you can simplify it. And they ask children, school children, say 1 plus 2 plus 3 plus up to 10 is 55. Then what it is, if it is 11 plus 12 plus up to 20, what it is. So some students start adding calculator and so on, but some students are very intelligent. Those who do not start adding, what do they do? Can you think? I don't expect answer. Intelligent boys, how do they do it? Any idea? They do it, left side is 10, there are 10 tens. Right side, I have given them the answer, 55. So it is 155. So next one is 255, next that is 355. So that way you can add from 1 to 100 very easily. You don't have to say first number plus last number, multiply this number, that number, without thinking how it was developed. Anyway, so simple things, try to think why it happened, how it happened, and so on and so forth. Yeah, anybody has any questions so far?
Sir, I would like to add small thing here.
Yeah.
So whenever I go and discuss some doubts with Professor Rahman in his office, so you think like, I'm struggling from last 3 months, I'm not getting what I'm expected to get. So you think, okay, let's go and meet Professor Rahman and we'll get some ideas. So we go and meet him. And then as soon as you enter, you discuss your problem, sir will take you away from that problem and then give you a puzzle to solve. And that puzzle carries the answer to your problem. So I remember this question, 1 plus 2 plus 3 plus 10 is 55, then 11 to 20 is how much? So I discussed my problem, Prof gave me this problem, and then Prof said, okay, you go back and think. So I went back and I thought that how this problem is so simple. Like when you try doing it in simple way, first add the first tens and then 55, it becomes 155. So my problem was also that simple, what I was not getting from last 3 months. I went back and thought about it in that simple way, I got the answer. So this is like sometimes you don't have to apply like formulas and then complicated equations to get your answers. So this is how Prof helped me to solve the small problem. So just to add to that part what Prof was saying.
Simply think about what is the problem. In his case, problem was this: when arcing takes place, it is welding. So why don't you take the advantage of welding, because it is a large amount of material removal. Anyway, so and here this problem, I think I discussed verbally. I give you the case study as well. This was a thesis, master's thesis, evaluation of CBN tools for high-speed machining. I think I discussed it. No, we didn't? Okay. There was a student from India, Zarina. She was also from Chennai, South, female student, and she says, give me some interesting project. Because master students, we don't insist, because master students project is not compulsory. They can do it through coursework, a simple project and do. She said, no, I opt to do my master's through research. There are two parts. So she decided to do through research. At that time, we got a funding from US University for 250,000 to develop a tool or a cutting process by which we can do machining of aluminum, titanium alloy at very high cutting speed. So, as I told you, I never say no usually. It was a joke, even if my wife wants to buy a sari, I never say that, don't buy a sari, I don't have money. I say that, cut down the cost, minimize the number. So, anyway, so she's not around, don't go and tell her that, Jesus. So, it's just fun, for fun. I think. She's very careful, cautious, and again, praising wife too much is also not very, very good. I praise her, definitely I praise her very much. Okay. So this is the student, Rahmat Zarina Abdullah. Yeah, Rahmat Zarina Abdullah, me and Professor Wong Yaksan, who is idiom specialist. Okay, so where to start? I do not know where is the solution. Actually, I didn't know. Dean came and said, hey, Rahman, you will have to do it, because I have got the funding and this money is for you, but you have to do this project. So out of respect, I told him, okay. And moreover, Dean, if I antagonize Dean, means my promotion, everything is gone. So I said, okay, I will do it. So Zarina, would you like to try it? Said, so sir, I do not know head or tail of it. If you ask me, I will try. Okay. So then I asked her to study. So again, I'm talking about how to do the research. First thing, after getting the topic, or to get the topic, you do a lot of background work. For her case, she didn't have much time to do a lot of background work. So the project was given to her. She gladly accepted. And that time I was also very young researcher. I wanted to get more papers, more visibility, and so on. So I gave her this project. And moreover, she was doing her master's, not much time to dwell on. So project. So then she studied and found carbide tools are commonly used. And for carbide tools, cutting speed does not go beyond 40 meters per minute, and tool life is very short. So they continuously change the tool and go on machining, and that is, but I don't understand, I was surprised, puzzled, why they do not follow the basic rules and fundamentals, that a tool must be much harder than the workpiece material. Tungsten carbide, to machine titanium alloy, which is very hard, and for titanium alloy, in corner and all these things, they have the problem of work hardening while machining. People are happily using it. So I say this is a good project, and cutting at 40 meters per minute, tool life is too short. And there is a special grade of carbide which is used for machining, cutting steel. This is not also suitable. And the coated tools, he studied and found all coated carbide tools show greater wear rate than straight grade of cemented carbide. So that's why when people talk to me about coating, I'm not very much in favor of coating. Try to go for higher grade, stronger grade, more sustainable grade rather than coating. Then look for ceramic tools, low thermal conductivity and high chemical reactivity with aluminum alloy, titanium alloy. And what is the other disadvantage of ceramic tools? Brittle material, so they cannot take impact. And cutting speed range also for ceramic, it goes from 30 to 100 meters per minute. The tool life is not satisfactory. And it causes rapid tool wear, high temperature produced, and all these problems are there. Low thermal conductivity, chemical reactivity, high strength cannot be maintained at elevated temperature, low modulus of elasticity. And again, since our target is high speed machining, they gave the target of 250 to 400 meter per minute. So we will have to increase the cutting speed so that we can increase the metal removal rate. Target was 250 to 400 meter per minute. And this actually too early to come to the conclusion thing, we thought of going for CBN. And then we started with CBN, and we used high pressure coolant of 70 bar to flush away the chips, take away the temperature. Actually in high speed machining, flat coolant doesn't help. So I will leave it for discussion. Flat coolant, any sort of coolant doesn't help much. High pressure coolant enhances the machining performance. If it is high pressure coolant, that helps, because your target is to put the cutting fluid on the cutting edge. If it is just flat coolant, if you don't forcefully send it to the cutting edge, it is useless. So we decided to go for high pressure coolant. And I told the student, you try, just go ahead and cut it. So she tried, cutting speed of 350 meter per minute, and depth of cut 0.05 millimeter, feed rate was 0.05 per tooth. It was milling operation, yes, it was milling operation. And then we tried changing the depth of cut and feed rate, double, then cutting higher cutting speed, lower depth of cut and feed rate, and in all the cases you see the cutting edge at this speed did not survive more than half a minute. Tool became blunt and she started crying. She was very upset. She said, "Sir, I'm not going to get my degree." I said, no, don't worry. I took it. They said, "Degree is with me. I'll just hand over it from my hand to your hand, that's all. I guarantee it." She said, how can it be, sir? The tool doesn't survive. I said, is it the only tool on earth which should be used? I thought CBN is much harder than titanium alloy. You just use it, and you failed. So what? So I convinced her. I said, and Professor Wong, who is EDM person, he was also puzzled. Hey Rahman, how will you do it? I said, wait, let's see. So we sat down and discussed and said, well, find out the cause of this wear. First of all, find the cause. And its effect, we know that it causes, that cause is affecting the tool life. Tool wear is blunt. So find out the cause, why it is happening. So how to do it? So first of all, you take the tool, you know the composition, yet you do XRD analysis to find the composition of the tool. Then you know the composition of the titanium alloy, keep it in your hand, and after machining, you again analyze the cutting edge and analyze the chip and see what you find. That gave us the solution. So you don't give up. Go into the root of it, find the causes and the effect, and you will get the solution. So that means immediately that time you would have given up that end of it. Never ever give up. And have conviction, keep the parallel processor on, think of alternate solutions, and you will reach there. So what do you do it? Picture is not very clear, I think. Okay, insert, when we analyze the insert, initial virgin insert, you had titanium, vanadium, aluminum in it, and don't consider this side. Machining the chip, if you machine chip with diffused boron and cobalt, it also has boron. Insert had one CBN, cubic boron nitride. So it had boron, and we found cobalt, correct? With the chip. So chip, cutting chip had no boron. And cutting chip got boron because the boron, the binder of the CBN tool, migrated and moved to the workpiece. Diffusion took place because of high temperature. So the work was to stop this boron from migrating or diffusing. Now how to stop it? So he called the tool manufacturer, this is happening. They said, okay, let us think of something, and we gave our suggestion that stop the migration of boron, migration of cobalt, or you bind the particles without cobalt. They said impossible, it cannot be done. But anyway, they took the problem with them and they went to Japan, and after 3 months they came, yes, it has been done. Here is the chip. The insert has no cobalt in it. We also suggested that if you try to compact them at high temperature and pressure without the binder cobalt, and they did it. So they developed a tool. It is pure CBN, that is, it is binderless CBN without any cobalt. Okay? And with that, when we machined, we analyzed the chip, pure CBN, and chip did not have any cobalt because there was no cobalt in the tool. Does it make sense? So you know the cause, you know how to remove that cause. But again, if you have a headache, don't try to cut the head to get rid of the headache. So try to get some tablet. Okay, then so we have a new tool, initial conventional tool. The tool varies so much, but when we brought binderless CBN, BCBN, binderless CBN insert, same cutting speed, same cutting conditions, tool wear is almost nil. Correct? Sorry? Tool wear is nil. Tool wear is almost nil. Very insignificant. And for that, and the cutting speed was very high. And if you took a CBN tool, tool life is in minute or tool life is in meter, two values, one is enough actually. So CBN tool, binderless CBN tool, you see how many times longer, and in different cutting speeds and different cutting conditions. In every condition, the binderless CBN tool was extremely high. And tool wear with CBN tool and with BCBN tool. And we compared the result with PCD tool, polycrystalline diamond tool, and CBN tool. PCD tool is this green line at a cutting speed of 350 meter per minute, and quite comparable. Binderless CBN tool wear was slightly more, but quite comparable. But when it comes to different feed rate and depth of cut, they are at par. So problems are there. Think quietly, carefully, keeping your cool. Most importantly, parallel processor on, that there are other options, other solutions as well. Okay? The conclusions I've already told, so I don't have to tell the conclusions again. Binderless CBN, its benefits, and be up to date. The last point is be up to date with research. Example is ductile mode machining of brittle material. I've already discussed about it, and I had so many options. I could have chosen example from all these. So I have taken the example of Arif, example of ductile mode machining of brittle material. I don't have to elaborate on it now. So I quickly skip. Correct? Now, do I have time limit or I can continue, Prof? I can continue. Half an hour. Okay, up to you. Up to you. Okay. This one. I think. Oh God. I thought I have discussed enough on modeling and diamond turning process. Do you still some more input?
If it's readily available, you can do that.
I can give you.
Or in the afternoon, sir.
Afternoon, let me think. Afternoon I'll be talking about research proposal and thesis. But I think I've given you an example. When you have a problem, look at the variables and put them in a suitable equation, do the finite element analysis or some sort of analysis or geometrical analysis, and then verify them experimentally. That is, I can give you more and more examples, but in your application you'll have to think which equation is most appropriate, use that. Okay, let me think about, but let me finish this. This is important. Oh, are you going for tea? Okay, okay. This is very important. Please come back, all of you, how to be a good researcher or what is expected from a good researcher. Okay? And please also come for the afternoon session. I'm sure you'd like to know how, at least my view of writing a paper. Feel free to argue and discuss. Today everybody is so quiet, no question, nothing. I don't know why. Okay. Now, honors on you. Are you a good researcher? Okay. A good researcher. I'm sorry to put such a harsh word. Must be. Please. Sincere, hardworking, devoted, all adjectives. So put in your heart. Okay? And I should not give example. Sincerity, I leave it to you. Don't try to fabricate data or manipulate data. Okay? And work hard to get data. Don't try to cut it. Make a shortcut. Thoughtful. Inquisitive. Always should have inquisitive mind. Creative. Intelligent. And ultimately, later at old age, become wise. Must be able to think outside the box. Must think of multiple options. Parallel processor should be on. Okay? It's not past journey, it is life journey, so be serious. Must have strong fundamental knowledge. What I told earlier, I'm just repeating those things. Be a good team player. You're trying to learn something, you're trying to share your knowledge with something, that your depth and breadth of knowledge becomes wider and deeper. What I was practicing regular seminar in the group, discussion among group members. That way, doing one project, you know about many projects. Should have passion for research. Don't work for degree. Please work for your own satisfaction. To claim that you know something, you have done something, be proud of your own holding. You should have analytical mind to solve problems which you encounter. Otherwise, you'll end up as an experiment and not a research work. Should feel the ownership of the project, please. Professor asked me to do it, I do it, no. At least professor should inspire you to do it, you get inspired. And I tell to me and to my students, I don't tell my students, I tell to me, I'm just waiting to create a spark, give a spark in him so that his eyes glow and say, yes, I've got something. And try to do it. You should be sincere, serious, cooperative. If the teacher sees that, oh guy, he comes at 2 o'clock, goes at 3 o'clock, sometime he comes, sometime he doesn't come. Your sincerity will inspire the supervisor, and supervisors vice versa, looking at your sincerity and seriousness, he'll be happy to share his knowledge and guide you. So it's a teamwork. And in my case, I feel once I take a PhD student, I don't treat him as a student, rather I took him as a co-worker, colleague or whatever it is. The relationship is very important in postgraduate level. Parallel processing capability, should be able to think multiple possibilities. Okay. Then I have already told analysis, when you do a study to conduct a good research, analysis followed by experimental verification, or experimental investigation followed by analytical solution. And I repeat, analysis should be based on not statistical analysis, it should be geometrical analysis, mathematical analysis, physical analysis, whatever you name it, it should be supported by fundamentals. And each fundamental factor coming in the equation should be evaluated, analyzed and elaborated, which is done by finite element analysis. So that you can freely vary the parameters to see that. For instance, I give you an example. When you saw that extrusion, if the range would not be considered from almost zero chip thickness to more than edge radius chip thickness, I hope you remember that picture. If the whole range would not be investigated, extrusion level would never be invented. And in the past they did not do it. That's why they were contented. Merchant said, that is the word in the Bible, plowing and sharing. But it's not a challenge, it is trying to go into the depth of it. But again, I heard the story from my direct supervisor about his supervisor. So try to bring in everything in mind, create interest in yourself. If I would not have any interest in Professor Masku's work, I don't know who would come forward to solve it. I'm thankful to God, thankful to my supervisor who told me the story, gave me the paper, I read it, and I reinvented the wheel. I reinvented the wheel after so many years. He did it in 1953, I think, and I solved it in 2010. Okay? So, carry the legacy. Okay? So be up to date also. When it comes to exhibition, be flexible to make changes during execution as and when necessary. Don't be rigid. Even supervisor says so, and I tell you one story. One of my brilliant student, unfortunately there were two supervisors. So I told the student that if you do this way, you'll get fantastic breakthrough result. Because here I would like to elaborately, time is short, very quickly. Never try any shortcut, please. We wanted to see how the lubricant flow, not in a plane, when you have a shaft and a bearing around it, if the bearing and the shaft are fitted and by the keyway you clamp it. I hope you remember the bearing and shaft assembly. You need a keyway and then fix it with pin so that it remains seated. Now, and if it is to rotate something, then you need to ensure that the lubricant flow is there. So the grease, all these things are given, correct? And all this, the flow, and every time you need to replenish it with new grease or new lubricant. If you could ensure there is some pocket between the two frictional surfaces, so that when you input the lubricant or grease, during rotation it will splash from the pocket, we call it pocket, from the pocket, then this grease or lubricant will last long. So for that, concept of making a pocket between two friction surfaces is good idea. But how do you do it? If you want to do it, that pocket created by, try to follow very carefully, by laser. And laser is a non-deterministic process and it's never a smooth surface. So whatever analysis you do of the result will be non-deterministic, because the surface you have generated is non-deterministic, probabilistic. So I requested the student to machine the surface with ultra precision, make the pocket with ultra precision with defined geometry, so that your prediction, calculation, everything will be authenticated. But the other supervisor, no, in my presence he didn't say that. The student said, no, rubbish, so long you create a feature. So the student created the feature, did work, and got an improvement of 10-15%. And during this execution of PhD, for some reason, that supervisor, young guy, he wanted to have more publication, get some result quickly, chasing the student to get more and more papers and so on. And got results, published, tried to publish paper, all gets rejected. And finally, I said, hey, better write your thesis, get your degree. So wrote the paper, got the degree, could not publish paper. And I don't know whether finally could publish paper or not, but it was very difficult task. So after PhD, the student came to talk to me about her future job. So I nicely asked the student, why did you not that defined pocket? Cried and said, other supervisor did not allow me to do it. So I'm not trying to undermine the position, but when you do something, even if one supervisor says no, I said, why did you not tell me that story? I would have managed it. I would have get it done by the technician, and you could have just used it. So tactfully, go along with your conviction, with the analysis. Don't get afraid of supervisor. So try to do it very tactfully if it is a reasonable solution. Okay, so flexibility, humbleness, all this comes in. Try to get maximum output with minimum input, and to get maximum output, minimum input. When I get students from Thailand or Vietnam, those who do not have research background, and when they do experiments, was that student? Yeah, Mantang. He was doing experiment. So he was also doing gun drilling by conventional method, very good student, but when he was getting the results, cutting speed, he was varying 50 meter per minute, 70 meter per minute, and then 75 meter, 105 meter. So I was not the main supervisor, so I didn't have much access, and during presentation, all these details were not discussed. He was getting funny results. So one day I called him and, hey, what has happened? Let me see the details. How have you designed your experiment? I never go for so-called design of experiment, 3 factorial factors, no. All my students will have to do actual number, cutting speed variation from this. So he showed me all these things. I said, why do you do that? He said, sir, different cutting speed. I said, no, there should be some logic. You are varying at steps. If it is 20, it should be next 40, 60, 80, 100, so that you can get some trend. Sir, it should give the same thing. I said, no, don't do that. Have some logic behind it. So then he says, okay. Then he quickly started. And once you design it properly, please be careful, cautious. I'm sure all of you will do it because you have your research background. Those who do not have it, they will. Is it working? Microphone. So when you design, and never ever try to do 3-point graph, minimum 4 points, and 5 points should be good enough. Please remember, 2 points do not give anything. So if I get a thesis from India with 2 points, I don't reject it, but I make it compulsory that 2-point graph should be converted into at least 4-point graph. Remember that, okay? At least 4 points, because 2 point doesn't give any trend. 3 points also gives a trend, but 4th point could be quite different. So then you will have to go for 5th point. Please logically try to understand why it is. To understand the trend, I prefer you should go for at least 5 points. And points should not be very close to each other. Points should be spread in such a way that you get the trend. Once you get the trend, to fine tune it, you try to choose points in between to confirm it or reconfirm it, okay? So please be mindful about all these things. So that shows your sincerity and seriousness. Okay, think of writing a paper during execution. So when you do experiments and all these, keep that in mind, because without 3 points you cannot get any train, so you cannot write a paper. So all these things you should remember, and get the parameters which are critical and useful. And if you are studying the cutting speed, for instance, effect of cutting speed, don't try to be too detailed. Get the trend. We are as an academician, we are supposed to set the trend. We are not in the industry to get into the very details of it. Very detail is to substantiate it, because you are not developing a commercial product. We are giving an academic value trend of something. So please remember that. Too much of nitty-gritty detail not necessary. You do it only when authentication, substantiation is necessary. And that's why when my professor was giving me paper, his very good papers to read, and he would ask me, "Hey Rahman, have you got something to do research?" I said, "Yes sir, your paper I read, something you have not done, let me do it." He said, no, never ever do it. Never follow my work, do something new, something that. All these I'm giving you just to have a feel what is research, how to get new things. Okay? So when you do the work, think of writing a paper, do an extra experiment when you have any doubt about any outcome of the experiment. Otherwise not. But again, having said that, each point you are studying cutting speed, effect of cutting speed at 20 meters per minute. Preferably try to do 3 experiments. Do 1 experiment, do another experiment. If you see a significant variation, then go for the 3rd experiment. Then you see the variation. 3 experiments for each point is preferable. Don't be happy with 1. Okay? That may lead to frustration, because you are not sure whether the results are right or wrong. Sorry, avoid statistical solution, because it gives what has happened and does not answer why it has happened. Please remember that. One can start with an empirical equation. The solution doesn't matter, but needs to keep in mind how to build the analytical solution. 2 years back, Richard Thaler got his economic Nobel Prize, and because his empirical equation is substantiated by analytical solution. Otherwise, he would not have. He has written himself, if I would not have done the analytical solution, I would not have got the Nobel Prize. Okay? Some problems I've given you already. Think manufacturing without tolerancing. Each parameter you come out without tolerancing, you can get a paper. Trend of manufacturing. Okay, my question now. What is the trend of manufacturing? Manufacturing trend is large volume, small variety, or small volume, large variety. Small volume, large variety. Have you thought about it? What decides the volume? Give an answer. You didn't think. I'm so sorry for that. Please don't do that. Think about it. If the answer is so ready-made, then I would not have asked you. Sorry? Sustainable. Okay, sustainability. Any other? Which decides the volume? Demand. Do you think people develop product based on demand? Steve Jobs did it based on demand. He never thought of demand. He did something, I will not tell you why he did it. Do I know? I don't know whether there is a demand for simultaneous EDM, ECM. Did I go for market survey? No. I did this DT machine, this micro machine. I didn't survey the market. What decides the volume? Because you saw my machine. No. Multiple function. Of course you are right, but what sets the volume? Multiple function is one, definitely. I'm not discouraging. Just It's definitely one. Innovation, yes, innovation. What else? You are right, but I want a broader definition of it. Sorry? Uniqueness, yes. Then why do you say that market trend? It is not the market trend. It is what? User friendliness, yes. So there are so many factors, correct? Prospect of it. So you are slowly coming out from the trend you announced, small volume, large variety. Give me a second, I'll show you the graph. I'll show you the picture, should I? Oh, I have no time. Afternoon I'll show you. What sets the trend? Need. Yes, need, but no doubt. But Steve Jobs did not know what is the need. But he developed. I'm giving you a hint also. What Steve Jobs did. It is the level of technology which decides the trend. Correct? When there is no radio, the radio came. People could hear the voice of one person from long distance. So radio became so popular. Philips was making the radio, big one. You have not seen that. Like a huge TV on the table. When we were a child, in our whole PS, there was one radio. To listen to the news, the chairman of this union and people from other union would come. His whole ground would be full in listening to the radio. Only one manufacturer, Philips. Okay. When television came, so that was a breakthrough, radio. When television came, people not only hear, they can see. Oh God, it's a fantastic breakthrough. When television came, then it started making black and white, small screen, big screen, curved screen, straight screen, thin screen, all these changes came. These are all incremental. But the television itself is a breakthrough innovation. That is called a revolutionary innovation. And small changes are evolutionary innovation. Correct? So, when mobile phone came, mobile phone was first by Motorola, I think. I always love to find the first product. I bought a Motorola, huge. I cannot put it in pocket, so I was carrying, and one of my colleagues, Professor Enduni, oh, the man with the big telephone. It's a huge thing, but I loved it. And then came Nokia, folded, very big. I couldn't put it in the pocket, and I lost it in Dhaka. I lost it in the scooter, but I got it back. The driver was a very nice guy. Long story, I will not tell you. And so, when handphone came, Motorola started. Nokia, Sony, Panasonic, and so on. So many people. Then variety started. So volume becomes smaller and smaller. So when revolutionary innovation comes in, volume is large. When evolution starts, then volume becomes small, variety becomes large. So it is, the trend is set by the level of technology, not by the product. Okay? Please remember that. So people think I always go against the wind. No, it's not. They rather go, they just ride on something, and so don't be that, okay? So trend of manufacturing, our work is, those who are innovators, their responsibility is to change the trend. I'll show you a graph. Why you need to change the trend? If you follow the trend, simple, again I'll show the graph, time, because I need to go in another 5 minutes. The trend is to have your luxury of life, to improve your standard of living, you'll have to spend more and more energy. You need to have fridge, you need to have television, you need to have aircon, and so on and so forth. So energy has its limitation. So we will run short of energy. Then we are going for nuclear power, this and that. You saw the disaster, Chernobyl disaster, Japanese tsunami disaster. So all these, we cannot afford it. So Germany has already, they have stopped all the nuclear power plant. They are going to coal and whatnot. But it's not sustainable. So what Vinod said, to remain sustainable, we'll have to change the trend, save energy, yet standard of living must go up. Please remember that. So through innovation, we'll change the level of innovation, technology, and we try to bring in revolution. Trend of manufacturing. We need to change from volume versus quality. And anyway, surface. Now, I'm not going against anybody, but do you anticipate what is the problem of 3D printing? 3D printing is a huge trend. What is the problem of 3D printing? Strength. You can try to compact it, increase the strength, but still you cannot get rid of interparticle, nanoparticle, even nanoparticle, interparticle void, difficult to get. Even if you compress it, crack line still remains. If nanomachining goes to picomachining, then it will become chip thickness will be larger than edge radius. So you'll have to come to compression-based machining, and machining is the ultimate solution. I'm expecting too much. Machining is the ultimate solution. So we'll have to have nanomachining and even below nanomachining to 3D printing, compaction, and followed by fine finishing. I think we have no time to discuss about it. We'll have to go for 3D machining using elliptical vibration device or fast food servo. Finally, a little philosophical. I saw this actually, it's not my own, I saw this quotation. My wife was going to a gynecologist. It was written on her table. When we are unable to achieve the quotation written was that, oh God, help me to solve female problem. If I fail to solve the problem, please remind me to go back to you to ask for the solution. So I have rewritten it in my own language. When we are unable to achieve our targeted innovative objective, we should remember to go back to the Creator, the best of all innovators, to help us to reach to our target. Whatever we do, outcome should serve the humanity irrespective of any sort of differentiation. Thank you very much. Okay. Impact factor, even if you try to increase, unless you publish good paper, your impact factor will not go up. The journals is rated. All the journals are rated. Even if you publish a paper, if the rating of the journal is poor, then impact factor will not go up. Because everybody would like to publish in a better and better journal. So that's why the good journals have high impact factor, because more people read it, more citation. So publishing a paper, impact factor doesn't go up, citation doesn't go up, if it is not in good journal. Yes.
Sir, I see that Taylor and Ranchi and some stringent journals don't have an impact factor. Since they are running from around 20, 30 years back, but since they don't have an impact factor, what is the main reason?
No, it's not because of their history. ASME.
Yes, sir.
I got your question. If I'm wrong, you please help me. You see, ASME, General Manufacturing, very low impact factor. It is there for, I don't know how many years.
Around 2 point something, I guess.
ASME? No. ASM is Journal of Manufacturing.
Oh,
B,
ASM is General of Knowledge.
Series B is I think 2 point something. Not even, when I started it was only 1 point something. Yeah. Whereas if you look at Journal of Material Processing Technology, short life, now it has become close to 4, 3 point something. And Machine Tool Journal is 4 point something. CIRP started only. CIRP started not very long. Their journal
Yes.
became in the public domain and is considered for citation index close to 5, I think.
Actually, sir, my question is, some of the journals are running from around 20, 30 years back, but since they don't have an impact factor, why? Because I saw that some of the journals are Springer and Trailer from Francis.
No, because
Sir, I will Google it and will let you know.
impact factor does not go up because citation is not there.
No, but it's a very reputed journals.
No, if it is reputed, yeah, people are not reading. Reputation is based on how many people reads it.
And cite it.
Scientists, engineers. Yes.
Okay.
It's not the length of how many people
Okay,
read
sir.
it, how many people cites it. That gives the citation.
Okay, sir.
Cites it in his paper, in his own paper.
Okay, sir. Thank you.
Quantify? Research work. Recognition, citation. And if your research, there are many ways to evaluate. If your publication out of that research has good citation, if the funding authority thinks, oh, this guy has done good work, you get another funding, that leads to another funding, and the university gives you promotion, and what all these actually. There is a saying that if flower blooms, it will get its recognition definitely. Yeah. Any other question? Yeah, sure. Thank you very much.